Welcome back. In this lesson, we're going to look at water. You have a growing population. How are you going to make sure that you have enough water for everybody as cities grow all over the world? How do you keep that water clean? How do you protect it from pollutants and making sure that it's equitable to everyone? So let's look at some details together. Because water is so necessary, more wars have been fought over water probably than anything else. You usually do not have enough water to go around when you have a large population. And as the population increases, this will be the number one thing that people are worrying about as you were imagining growing a city, say in the middle of Las Vegas, in the middle of the desert. How do you have a city that has millions of people in it in a place where there isn't any water? So all of these, especially in the Southwest, these cities in the Southwest where it's normally an arid or semi-arid situation, the idea of providing water that anybody wants at any amount at any time is a serious issue and one that requires a lot of thought. So number one on people's agenda is to try to teach conservation, that you do not need to squander this just because you can, because if it's limited and there is a huge demand for it, there will be some people that will not have it, that you end up with haves and have-nots, and that is always a recipe for social unrest. And so conserving water especially, and other resources more broadly, is something that can help very much. So most of the water use is by farming. And so how you irrigate your land so that the plants can grow does determine how much water that you actually use. Another huge user of water is industry, mostly for cooling things. So tanks that cool down machinery would be using enormous amounts of water. And then so if you could develop technologies that would use less water, then that's more water that can be used in other ways for other people. Of course, pollution is always going to be an issue. If you have a point source of pollution, that is like a pipe coming out of the ground from some kind of an industry or some type, then that is a point source of pollution. That one place is causing industry, or is causing pollution. It is possible to have a non-point source, something more general or everywhere. So let's imagine that there's lots and lots of chemicals being put on the roads to keep them from being iced, or from the fields to help the plants grow or to kill the pests. If all of that water that rains on that then goes into the groundwater, that groundwater could be polluted by these sources, and it's kind of an everywhere at once idea. So it would be a non-point source. So there's all kinds of ways that the groundwater can be polluted. Tanks can be polluted. I know that in Charleston area a couple of years ago, there was some huge tanks that broke, and the water got into, or the whatever it was stored, some kind of a mining material, mining solvent, was put into the rivers and then into the groundwater, and there was hundreds of thousands of people impacted in terms of no safe drinking water for weeks on end. So this was a big deal. So there's various ways that groundwater can be polluted. You can have a faulty septic system. You can have the field pesticides, as I mentioned, and different types of chemicals. The stuff that's seeping out of a landfill can go into the water, and all different types of contaminants. Also, depending upon where that water is stored, there can be contamination even in after it's drawn out of the ground. For a long time, people have been dumping in the ocean, thinking that it was just an inexhaustible place, that it's so big that it could take anything you would dump into it. You're going to see that that's not always going to be the case. The oceans are seriously polluted. There is tons and tons of plastic trash in the oceans that's impacting the marine life. There's all kinds of chemicals and different types of fluids that are being put into the water just directly drained into the ocean because it's so big. People think they can get away with it. Also, there's various contaminants that will get into the air and then eventually into the water. Mercury being one, a very heavy metal. And certain fish will eat other fish that are very high levels of mercury. So I know the tuna industry is really seriously interested in this, because people eating tuna can actually increase their mercury level, which is a poison, and cause all kinds of defects and impair health among people who would eat these things. So that's another potential contaminant. In the 1970s in the United States, there were two major landmark bills that were passed into law to try to clean up the water, because they found at the end of the 70s, or at the beginning of the end of the 60s, there was so much pollution in the water. Water you couldn't swim in it, you could not drink it. Much of the water lake system and river system in the United States was so severely polluted that they started doing something about it. And there was environmental protection acts on water, specifically the Clean Water Act, and then later the Safe Drinking Water Act, which made it a right for all people to be able to gain access to clean drinking water, not just rich people who lived in rich places, but every person should be having access to clean drinking water. Even now, when you see older kind of aged cities that have lead pipes from decades ago, it's the Safe Drinking Water Act that people are appealing to, that everybody, no matter what neighborhood they live in, has the right to turn on the tap and have clean water that's not going to actually hurt them. So the water quality has improved over the last decades. There's still quite a lot of lakes and rivers that are polluted, but not anything close to what it was at the end of the 1960s.